Hi guys, this is another trigonometry video on the unit circle and sine cosine graphs. We're kind of bringing a lot of big ideas in trigonometry all together. So this will be a bit of a quick video, but you might have to reference it to other things that we've done, or maybe it'll help you get ideas altogether. Right, here's a unit circle. It is 1 unit in radius, and its center is at the origin, and you can see it going around and all the coordinates there. I've divided it up into 15-degree segments here, but I've highlighted 30 degrees, 45, 60, 90, and then the same corresponding things over here, which you'll understand in a minute, hopefully. You can probably predict what I'm going to do anyway. Okay, if we take this triangle for an example, alright, this is a 45-degree triangle. Since the radius is 1, the hypotenuse of the triangle is 1, so the x coordinate and y coordinate will be the same, and by Pythagoras it's root 2 on 2, or 1 on root 2, which is 0.707. Okay, but if we take that same triangle and reflect it and reflect it and reflect it, you get these 3 other triangles, and all 4 triangles here are congruent. So all their sides are the same length. Well, the hypotenuses are all 1, and all the other sides are 0.707, 1 on root 2. So you can see that all the coordinates of these points have the same value, or absolute value, but just the pluses and minuses change. Okay, so and each of these 4 points are 45 degrees from the x-axis. So 45 degrees, 135 degrees, 225 degrees, and 315 degrees are all, there's 45 degrees in here, 45 degrees from the x-axis. Okay, this triangle here has an angle in here of 30 degrees from the x-axis. You know that hypotenuse there is 1, and because a 30-60 triangle is half of an equilateral triangle, so this will be half of 1, and Pythagoras tells you this will be root 3 over 2. So those 2 values there tell you the coordinates here. Root 3 on 2 is 0.866, and a half is 0.5. Okay, now this yellow triangle is congruent to these 3 other yellow triangles, and all 4 triangles are 30 degrees from the x-axis. So the coordinates at these 3 other points are the same as in this reference angle in the first quadrant. Okay, so 0.866, 0.5, and then the others are the same, just with the positives and negatives flipping around. Okay, now this green triangle is congruent to the yellow triangle because that's 30 degrees now, so this is 60 degrees. So, and you'll see that the numbers here are the same as the numbers here, just the order's changed. And the same with these 3 triangles, the numbers are the same, just the positive and negative signs have changed. Okay, so what you've got there is your important trigonometric ratios for sine and cos. So as you will remember, the x value is cos and the y value is sine. Okay, so you can now remember the sine and cos values for all these angles here with the little dots on them. Okay, we're going to take that information now and we're going to redraw it on this circle diagram, but also redraw it as a graph. Now the axis over here on the circle diagram are x, y. The axes here are really y and theta, so this one will be sine, which is the y value. This one here will be cosine, which is the x value over here, but we'll see how that works now. Okay, at 30 degrees, this one here, that red line is 0.5, that's sine. Excuse me. The green line is root 3 on 2, 0.866, so I put that in there for cos. We continue with the next one and continue plotting it around. Okay, so the values here in this first quadrant are reflected in the second quadrant. So you can just put the same numbers in there, just changing the positive and negative signs, but you'll put the symmetrical values over here, and then continue around in the third quadrant and continue around in the fourth quadrant. And what you get is the red graph here is the graph of the y coordinates here, so it's y equals sine x, and the green one is the graph of the x coordinates, so it's y equals cos x. I probably should have made that theta, but there you go. I hope that's understandable and useful, and a good reminder of what you've done in class. Alright, have fun with doing trigonometry.